You are muted.
Can you hear me now? Okay, can you see my slide presentation?
I can see it. It's still in sort of present. Yep.
How about that? I'm
Perfect.
sorry. Yeah, you know, I should have practiced this. Like, remember we said I don't need to practice this in the beginning? I guess I should have. Sorry about that. Let me start over again.
You had it and it looked great. So whatever you did can do the same thing.
All right, let's see if I can do this again. Sorry. Share the screen. Okay, all right, good. Just, for some reason, my notes, there they are. Okay, good. Sorry about the delay there, folks. Okay, so yeah, thank you, Lisa and Vincent, for inviting us to have a talk here. I'm going to discuss with you these designed ecosystems that are increasingly common in Florida and actually everywhere in urban and urbanizing landscapes, stormwater ponds. First, some outline of my talk. I figured it would be useful to highlight sort of the need for stormwater management. I think everyone here probably knows that, but let's all be on the same page, and then highlight what stormwater ponds are, their intended function, and discuss whether or not they're achieving their goals. And then look at potential utility of stormwater pond plantings. What are the potential benefits of stormwater pond plantings to water quality? What are some additional benefits? And briefly highlight some design considerations. And then I'll hand off the talk to Beth, who will really discuss a kind of a new project that's ongoing, utilizing plant material, not necessarily for stormwater management. So, okay, so this historically, before we have urbanization, this is what we can expect stormwater runoff to do from our natural landscapes. The majority of it is really infiltrates into the ground, back into our drinking water, back into our aquifer. And a small proportion of that runs off into nearby surface waters. Of course, when we develop, this is flipped. We have very little infiltration going back into our aquifers and our groundwater. And the majority of stuff runs off of our very impervious urban landscapes and runs into our natural water bodies. And of course, that creates downstream flooding issues, because there's an increase in volume reaching our surface waters. And it also creates problems for pollution, because all of the stuff that's on our surface of our urban landscapes just washes off now. So that needs to be managed, and stormwater ponds are the go-to BMP for this, best management practice for this, and I'll discuss why. And there's really two different types that you'll see, and depending on where you are in the landscape, it dictates which ones are really used. There's temporary retention ponds and permanent detention ponds. So the temporary retention ponds, both of these capture water that runs off of the urban landscape, and it flows into them, stormwater, before it enters natural water bodies. For the temporary one, the water then is captured here, and they're designed to dry out over a 72-hour period while the water infiltrates into the ground. And it's assumed that the pollutants and what's in that water is retained in the soil before it hits our drinking water. Whereas the permanent detention ponds, the water flows into here, and it's assumed that pollution is then either settles out into the water column and at the bottom of the stormwater pond, or is consumed or assimilated through biological processes into plant, algal biomass, or microbial processes cause denitrification and allows nutrients to escape into the atmosphere. And that's really the two pollutants, or some of the pollutants of major concern in Florida and other urban areas, are really nutrients that run off of our landscapes, because those nutrients have detrimental impacts to downstream water quality. So we're looking at nitrogen and phosphorus typically. Now we dig these holes, and when we say we, the engineers dig these holes to capture a certain volume of water. But surprisingly, these holes can become very different from one another. Here's ones by the Department of Transportation. Here's ones along homes that look like golf courses. Some are really just left alone to look like wetlands, really. So it's surprisingly becoming a diverse ecosystem, believe it or not. So again, they're managing urban water runoff for flood control and pollution control. I became interested in these things because I look at them and I see ecosystems in them, surprisingly. It's a whole of water, and with water and ecosystems assemble. For example, here's a limpkin. This is a bird of once of concern in Florida, which numbers are rebounding. And it's actually rebounding because the introduction of an invasive snail, the apple snails, providing a food resource, which of course these apple snails also live in stormwater ponds. Stormwater ponds have very high levels of invertebrate diversity. Sometimes they actually have more diversity in our urban ponds than they do in our natural ponds, which is interesting. They have fish communities in them. These, of course, these are tilapia. They're not native to Florida, but it is a fish community. And of course, we dig a hole and fill it with water in Florida, and eventually we're going to have our predator, the alligator, show up. So I see these things as they add biodiversity and ecology to our urban landscapes. Oops, I skipped a slide. So they're really increasing in commonality. They're increasing at rates at parallel urban development. And actually, this map shows how many there are in Florida. There's over 76,000 of these stormwater ponds in Florida. They're shown in blue. And that's a conservative estimate. The gray areas on the map are urban landscapes. And what this figure shows is the amount of space that urban stormwater ponds take up relative to other urban land cover types. And we see that they actually take up more space in industrial areas now, and they're competing with recreational and open lands. So there's not only a lot of them, they're actually taking up a lot of space. So why are there so many? Well, developers are required when they come up with a development plan to mitigate for post-development increases in flood risk and nitrogen and phosphorus loading, okay? Stormwater ponds are actually a very easy option. They're an efficient use of space. You can dig a deep hole in the ground to capture lots of stormwater, leaving plenty of room to develop. They also simultaneously address both flood and nutrient loading simultaneously. And they also provide fill for the site to build upon. So you can dig out this soil out of the ground, and now you can spread it out on your site to raise your home foundations up above the water table. And they're also presumed to meet standards regarding water quality. If you manage the correct amount of volume of water for flood control, it's assumed that you're also preventing 80% runoff of, or you're going to be creating a reduction in 80% reduction in total phosphorus, total nitrogen, and total suspended solids at runoff of urban landscapes. So are they doing their job? Okay, this is what Florida stormwater ponds are credited with: 80% removal of total nitrogen, total phosphorus, and total suspended solids. But we're finding out from the latest reports, or the most recent exhaustive reports of their efficacy at that, is they're not doing their job as effectively as they're credited for. They're only removing from about 60 to 65% of total phosphorus. And for nitrogen, it's much more variable, only 12 to 63%. And recent studies are showing that they can actually release inorganic nitrogen. That's nitrogen that's available for microbial and plants to uptake, which are a problem for water quality, through nitrogen fixation that occurs in the stormwater pond and the breakdown of organic matter in the stormwater pond, such as lawn clippings or yard waste or leaves that get into that stormwater pond that break down over time, and they're releasing inorganic nitrogen. So what we have to ask ourselves is, I'm missing a slide here, sorry, is with this many stormwater ponds, are they actually doing their job in the ecosystem? So my master's student, Kayla Hess, went out and did a study of that. And what she looked at was depressional isolated wetlands in urban landscapes. And she used these because they're interesting, because they're not attached to other overland flow water, to other water bodies. The only water really coming into them is stuff from that surrounds them. So the urban stormwater runoff, if you will. So she found 7 of them in Gainesville that were protected by stormwater ponds. So what that means is urban runoff runs into a stormwater pond before it enters this depressional wetlands. She found 6 that were not protected by stormwater ponds, so the urban runoff just runs directly into them. And then she compared the plant communities and soil and nitrogen levels in these depressional wetlands to non-urban wetlands that were not affected by urban runoff. And what she found was pretty interesting. There was actually no difference between the plant communities in unprotected and protected wetlands. So stormwater ponds don't seem to be having any impact on protecting these downstream ecosystems. So what she did find was that the urban environment, the wetlands, had elevated phosphorus, pH, and nitrogen in their soil and water. They had more non-native plant species. They had more facultative versus obligatory species. That means plant species that are more able to grow in more disturbed environments, and obligatory species which require more constant water levels. She also found more native species, but these were weedy, sort of disturbance tolerant species. And she found that largely these differences in plant community were driven by changes in soil and soil chemistry, and also some aspects of hydrology. But what it showed us was that we need to really find strategies to protect these urban wetlands from urban runoff, from the effects of urbanization on chemistry. Okay, and stormwater ponds are not actually doing that job quite effectively, at least not in Gainesville. So what we want to do now is think, okay, what can we do to improve the benefits of these ecosystems? There's 76,000 of them out there in the landscape and even more. So what can we do to improve them? And we worked on a project in Lakewood Ranch. This is outside of Tampa Bay. There are over 300 stormwater ponds in Lakewood Ranch, shown here in this map of, this Google map here. And this is what it looks like, an aerial view of Lakewood Ranch. And I don't know if anyone's familiar with this community, but people actually buy homes on stormwater ponds in this community, and they're sold them as a lakefront property. So people unknowingly buy homes as lakefront property. They think they're natural lakes, and they're really buying on a stormwater pond. And these homes actually cost sometimes $100,000 more than ones that aren't located on the stormwater ponds. So it's an interesting community. People really are attached to their stormwater ponds. And this is what's going on there. The way they manage these stormwater ponds is they put turf grass up to the edge of the waterfront. Believe it or not, over time, even though it's a shallow, well, it's a deep body of water, but a small body of water, slight wave action over time causes erosion that you see here. And this creates water quality issues. All of this total suspended solids fall off into the water and eventually release nutrients, creating unsightly algal blooms that the neighbors really complain about because they smell and they look bad. And another issue with this sort of management is that what happens is mowing, lawnmowers, and weed whacking puts nutrient-rich lawn clippings into the water. A really easy way to manage your water quality in these stormwater ponds is to avoid putting grass clippings in the stormwater pond. That's like just a very easy thing to do. But anyway, it results in these unsightly algal blooms that the neighbors don't like. And algae, even though it's part of the ecosystem, they don't like it. It looks ugly. But this does actually have some benefits regarding nutrient removal, but they don't like it. One of the simple solutions is really just don't mow around the edges of your stormwater pond. Leave that buffer zone. Prevent nutrients from running in. You prevent grass clippings from getting in the water. But residents really don't like that. And even if you plant native style plantings like this one here at Depot Park, they still don't like it. They think it looks messy and it blocks the view of the water that they paid to see. So this is a socioeconomic issue, preventing us from incorporating a potential BMP. So the Lakewood Ranch Interdistrict Authority approached us and they said, we're interested in improving the water quality in these lakes, but we're having an issue with the residents. They don't like the planting. So we're wondering if we can incorporate ornamental plants along the stormwater ponds, make them more landscape looking, and what would the benefits of that be? So could we actually improve water quality while preventing preventing people from being annoyed about these things looking messy? So they took on this project where they dedicated some funding to planting stormwater ponds 6 different stormwater ponds. And here's the stormwater pond planting designs. They didn't really approach us about plant species selection or anything. They just really looked for things that they thought looked nice landscaping wise. And they planted from 30 to 50% of the ponds. So there was about, and that cost them about $3,000 per pond. So if you do the math real quick and you do that by 76,000 stormwater ponds, we're looking at a value that's approaching 228 million dollars. It's an expensive amount of money if we're going to retrofit stormwater ponds. Okay, and this is still only 30 to 50% of the ponds that they planted. So here's what we did. We paired up these planted ponds with unplanted ponds that were quite similar to them. And we went out and we sampled water quality from inflows and outflows, also from the edges of the stormwater ponds and the center of the stormwater ponds, and planted ponds and non-planted ponds. And in the non-planted ponds, we also sampled areas that had stormwater pond plants in them and ones that did not. And we measured different metrics of available nitrogen availability and phosphorus availability. We did total nitrogen, total phosphorus, and then also forms of that are available for plant and nutrient uptake, orthophosphate, ammonium, and nitrate. And we also noted erosion around the banks of the ponds. And we did these samplings. We did a baseline sample in May, and then we sampled in the following fall, spring, and summer. And basically what we found, we actually found no difference whatsoever in water quality between unplanted and planted ponds. But we did see bank stabilization, improvements in bank stabilization. Now, if we were to sample more long-term, which we didn't have the funding for, perhaps we would have seen improvements in water quality due to the improvements in bank stabilization, but we don't know that for sure. But what we did see was something interesting. When we sampled that in the areas planted and not planted within the actual pond, we did see differences between these planted and unplanted areas with regard to phosphate. We saw a 23% reduction in phosphate in planted areas versus non-planted areas. And this was constant over time. So this suggests perhaps that plantings would benefit the water quality, but we have to do them at a greater volume than 20 to 50% or 30 to 50% of the ponds. So what we found was evidence that plantings can help water quality and bank stabilization, but we probably need to incorporate much more plant material into the stormwater ponds. And I put this down that not mowing around the edges of stormwater ponds is a very economical solution, right? Just prevent grass clippings from getting in there, prevent nutrients and fertilization runoff from getting in there. What we saw was likely the effect of the littoral plantings, those plantings growing out of the stormwater pond rather than the bank edges, for those differences we saw within the pond. So that suggests that we should probably explore littoral plantings a little more. We also saw that the residents were accepting of these plantings. They were contacting the homeowners associations and the interdistrict authority, and they wanted to have some plantings around their yards because they thought they were nice looking. So that's a plus, right? So if this is an effective BMP, we found a way to maybe make it appealing to homeowners. But we also want to consider the cost of prescriptive versus reactive plantings. Here we're looking at reactive plantings. They're reacting to water quality problems. What would the cost be to do this up front as opposed to after the fact? And we don't know what that is. These plantings were very expensive. What would it be to incorporate them in the design phase that we have to explore? So regarding littoral plantings, I want to just discuss one aspect of this. We saw evidence that they could be effective, but I want to just illustrate that it's not all clear and there's more research needed, okay? This is the nitrogen cycle. It's complex. I'm not really going to get into it, but what we assume is through plantings that plants are removing nutrients through their uptake and also through microbial denitrification, which means the microbes break down nitrogen and release it into the atmosphere as a form, as N2 gas. That's what we're assuming, but we also have to really be aware that it might not play out that way if we're not careful. For example, you could end up with organic matter falling off of plants at senesce, and getting into our water supplies and then breaking down over time and releasing inorganic nutrients. We also don't know what species are all effective at nutrient removal and which aren't. And we also need to understand the role of the microbes that actually live on plant roots versus the actual plant processes, the plant uptake as well. We need to explore that a little more. And these sorts of questions, answering these questions, can help to ensure that ponds are retaining the nutrients and not actually releasing them downstream. So something to think about. Other lessons we learned was this here on the left was a single species planting. This species is not dead. This is a sweet spire, very attractive shrub, but it's deciduous. It loses its leaves. And if we were to think of this, and the people didn't like that, residents like that, they didn't. They think they looked ugly. So you could improve the aesthetics of this by adding more species in there. And also, let's think about hypothetically, if this was a disease that took out this plant, okay, and killed everything, and it's the same species, then you lose the functionality of bank stabilization that the species might provide. Whereas if you use a lot of different species, and let's say a disease comes along and takes out this white flower, which is some sort of aster, I'm assuming, what happens is through diversity, the other plants are there to take up the slack and they actually retain that function. So there's a benefit to multi-species plantings. I'll just share this with you very quickly. We actually have a database through an EDIS document here that helps people to select plant species for their stormwater ponds based off of what functions and services they provide, as opposed to just what they look like, which is something we need to start doing a little more of. I will note though, data on nutrient uptake is sparse. Okay, so next steps. Well, it turns out that from this project in Lakewood Ranch, Manatee County became very interested and wanted to start to plant their stormwater ponds. So we're going to work with them to look at the efficacy of these stormwater pond plantings at nutrient removal, and also to identify educational and outreach strategies to promote stormwater pond plantings, and look at manicured versus more natural looking plantings as well. So which ones are more accepting, and also whether or not manicured versus natural looking stormwater pond plantings have any benefit to water quality. We're also looking at these additive benefits. This is a project in Jacksonville. It's along a rails to trail system in a lower income neighborhood. And we're working to plant this pond with natural plants and to enhance turtle habitat to provide residents with an opportunity for environmental and educational learning, for education. So again, I mentioned, or I did mention earlier with Lisa and Vincent, that Laura Warner did a research that shows that stormwater ponds are the water body in Florida that people are most connected to. It's the thing they most connect to daily. So this is, again, it's an opportunity for these plantings to serve another purpose, environmental education. And then we're also working with the Department of Transportation and some developers to a priori reimagine these stormwater ponds and enhance their efficacy of nutrient retention through increasing flow times, and also making them serve as more of a natural habitat, a human-made natural habitat, if you will, if that makes sense. But just to reimagine them up front before they're actually put in the ground. With that, I just want to thank everyone on my side who's been working on this project, and I'm going to pass this over to Beth.
Excellent.
Yeah.
Okay, so I'm going to share my screen. Sorry. Let's see. Okay. Can you guys see my slides?
Not yet. Nope.
Oh.
Nice shot. Hold on. I stopped sharing, correct? Okay. Yep.
Yes.
All right.
Okay, hold on. Okay, let me get out of there. Share screen. Sharing two. It's the worst when you have two screens because I can't.
Beth, if you share the actual PowerPoint, that works usually.
Okay.
The screen, yeah.
Okay, so I don't know how to do that. Sorry. Share. I've never done that, so I think I better share my screen.
Okay.
I'll figure it out. So if I share this, share. Okay, I think I'm almost there. Okay, how about now?
Yep, we can see your screen.
Can you see my presentation or the actual?
We see the notes.
Okay. All right. Stop share. I'm going to get there.
While we're waiting for Beth, I put the link to the EDIS document that Basil mentioned about the stormwater planting plant recommendations. That's in the chat box.
Thank you.
And we do have a question real quick if you want to tackle that while Beth gets herself situated.
Okay, what's it look like now?
That looks
Got it.
perfect.
Okay.
You got it.
Yay.
Okay, then we will hold off on the question
right.
until the end.
Okay. All
Thanks
right.
for your patience.
Okay, sorry. So thank you so much. So I'm really excited to be talking to you today. And I had said earlier that a really good benefit of this is that I was introduced to Basil, because at Orca, we basically, our focus is science-based solutions to pollution in the Indian River Lagoon. And so we collaborate really widely. And in fact, we are collaborating with UF IFAS Extension on this project I'm going to talk to you about. But I'm hoping that going forward, there'll be opportunities to collaborate with Basil and his group. But what I want to share with you today is a very specific project we're doing in Martin County. And it's a buffered shoreline demonstration project. So similar to the things that you just heard about around stormwater retention ponds, this is for Indian River Lagoon waterfront property. And so what we did, the idea is that putting in a buffer between the edge of the shoreline and the lagoon. And so we selected this Shepherd Park because it's such a central park. It's right in downtown Stuart. It's very frequently used. And so we worked with the city of Stuart, and we wanted to install a demonstration project of what a buffered shoreline would look like and do some before and after testing of pollution runoff. And then follow that up with a very targeted education and outreach project. So the way we did this, the first thing we did is we just went out and walked along here during heavy rain events. And so what we saw from that is we were able to see where the water was actually running off directly into the lagoon. And so that was primarily happening down here on the east end of the park near the boat ramp. There was not much direct runoff into the water down on this other end, because there are 4 drains that are in the park themselves, but those drains actually just go directly into this canal. So based on that, we did our pre-test, our baseline testing. We put out water collectors, again, along the shoreline down here where there was runoff, and then within the different drainage, the drains. And we got our baseline testing to see what kind of nutrients. So we looked at things beyond nutrients, but as Basil said, we're really focusing on nutrients. That's such a big problem for the lagoon, and a lot of it is coming from direct runoff from properties. So these data just show you the baseline data for the drains. These are the 4 drains that we tested, and we went during 3 major rain events to do our sample collection. So you can see pretty consistently, there is some nitrogen that's running off into these drains, but really high levels of phosphate. This is total phosphate. And then the same is true running off at that corner over here on this the right figure. It's for the 6, we put 6 individual collections at the runoff. And so these are our baseline data. Unfortunately, when I agreed to do this talk, I was absolutely certain that we would have our follow-up data. Unfortunately, it has taken us a year and a half to install our buffered shorelines. Everything that could possibly be kind of held up was with both the landscape architect as well as the the landscapers that we contracted with. It's just been a challenging time getting supplies, getting workers, getting people to do what you need them to do. So we don't yet have our follow-up data. Unfortunately, I'll share that with Lisa and she can disseminate it as soon as we have it. We'll be doing it very soon. It's actually storming right now. It would have been a great day. But just the kind of walk you through the project. So we had our baseline data, and then we worked with, because this is such a high profile area, and we do know, again, what Basil alluded to, that people want nice looking backyards. We have to present them with an alternative to what they have that's appealing. We contracted a landscape architect that a lot of the communities in Martin County use to do our planning, our landscape planning. And so we got the drawings from him and his group. And then they just got finished being installed last week. So they look beautiful. They were installed about 3 months ago, but there were all kinds of problems. I mean, it's, again, anything that can go wrong went wrong, but we are there now. And so what they did is they put these plantings and the mulch and then the rocks around the drains. And so as we know, all of these issues are so much more complicated than most people realize. And again, I think Basil did a really good job of explaining that. So we need to understand what we're doing and certainly not have unintended consequences that could possibly be more impactful than what we are trying to solve. But one of the main sort of very, very functional impacts of these buffered shorelines is that it keeps the grass. Just putting a buffer, just a physical buffer between where the grass ends and the water is, means that it's less likely that this grass is going to find its way into the water. And that is, we have consistently seen that this turf grass is a major contributor to the nutrients and the muck that's accumulating in the Indian River Lagoon. So the physical barrier, as well as the physical barrier of the water that's running in. So what we talk about is we're interested in capturing that first flush. So when, you know how we have these huge deluges. So when that happens, it's really just the first bit of water that runs off from all of this land where the dogs have been going to the bathroom. Even if people pick it up, there's residual nutrients, there's the urine, there's all kinds of things that are on this land. And so the first flush going into these drains is the major source of the nutrients and pollutants. So by putting in this mulch and putting these rocks around the drain, we're going to capture some of that first flush and keep it out of the lagoon. So that's the purpose of this project. Again, it's just finished. The signs are actually going in later this week. And so this is a demonstration educational site. So we're looking forward to getting the post testing. We hopefully will have that in the next month or so. But as we've been doing this, we've also been talking about how we can use this as a demonstration project. So these are the signs that are going up along the buffered shoreline. And I wanted to specifically point out that we are partnering with UF-IFAS Extension with respect to educating people about how to do this on their own waterfront property. So we are clearly not the experts on this. And so working with University of Florida and Extension, so we can educate people, we can share the science of how it's impactful, and then we can encourage them to do the same thing in their lots, on their properties, and then pass them off to the experts that can help them do that. One of the things when we talk about how expensive this is, and this particular project was pretty expensive because we had a landscape architect. We hired sort of a high-end landscaper to make sure it was very visually appealing. But there's other ways to do it. So we want to offer property owners a wide range of things that they can do as far as a buffered shoreline to have at least some impact. So that's what we're working on, kind of having this menu of options that people can do to change their backyards to mitigate nutrient and other pollution runoff. So what we are doing, we have this demonstration project at Shepherd Park, and what we're doing is a very targeted outreach and education. So what we did is we actually went in a boat all along the shore in Martin County, and we actually identified properties that look like these homes. So what we're talking about are people who have backyards, beautiful homes. They have backyards that have turf grass planted right up to the seawall. And so those are the most impactful. And so what we're doing is we are creating, so we actually have this survey. So like, for example, in the city of Stuart, 63.7% of waterfront properties look like those pictures I just showed you. That's all of those waterfront properties could benefit the lagoon by putting in a buffer of some sort. And so what we're doing is we are actually getting the names and addresses for those individual properties, and we're sending out a mailing, and we're inviting them to some events or educational opportunities that we're going to host at Shepherd Park, where we're going to bring a wide variety, certainly people from Extension, as well as some of the landscapers, so that they can talk to homeowners about their options, and then just providing them with very specific information about how they can change their property in a way that doesn't take away their view, but would decrease the amount of runoff from their backyards. And so we're hoping that this very targeted, non-confrontational way, because we don't think that anyone is intentionally polluting the lagoon. I mean, I live on a canal. I mean, people love to live on the water. And this is something that people don't realize. Even the idea of grass going into the lagoon, when we tell people about that, they're often surprised. They're almost always surprised. It's just not something that people realize. So sharing this information on a very specific, so it's not here's 10 things you can do, it's your backyard, this is what's the problem, and here's some solutions. So we're really hopeful that this is going to have a pretty significant impact. The city of Stuart is very excited about it, so we're going to be keeping track of those property owners that do add buffers to their shorelines and then we're going to have, kind of let them be role models in their communities. So we're really looking for kind of a comprehensive, collaborative outreach and education effort to see this through so it has a significant impact. So that's the project that we are doing. That is really all that I wanted to share with you. I'd be happy to answer questions. I do think that it's really important that we do these types of projects. We're doing other things where we share data with politicians, and we share data with cities and counties and state agencies. And there's a lot of big things that need to be done, but I think it's important to remember there's a lot of little things that need to be done as well. And certainly when we think about how many people live on the water, how many people have hardened shorelines, how many people have grass planted right up to those hardened shorelines, these little small things done by individuals can have a pretty significant impact. So that's actually all I have. So I'll be happy to answer questions.
Great, thank you so much, Beth. We have a bunch of questions rolling in.
Okay.
I'm going to start from the top. So Basil, the first one's going to be for you. And Maya asks if the ornamental plants in the Lakewood Ranch project, if they needed fertilizer.
Yeah, it's a good question. No, given the fact that they were on stormwater ponds, we really wanted that not fertilize those plants. What we did do when they installed them, I helped install the ugly planting that I showed the example of. It actually looks nice in the summer. I will give them credit for that. But what they would do is put a little bit of compost around the plant when it was installed. So there is that sort of aspect of nutrients, but no fertilizer at all for the plantings. Again, because it's on the bank of a stormwater pond. Yeah.
Great, thank you. And Beth, your first question is very similar. Sarah asks if the turf grass at the park is being fertilized.
The turf grass is not being fertilized. No, they don't have any fertilizer going on, and likewise, we ensured that they wouldn't do that on the plantings.
Okay, great. And Vincent asks if Orca's Kilroy systems or any other live water quality monitoring systems are able to pick up water quality signals from the first flush.
Well, certainly they all can. So we have the real-time Kilroys in the water. They're testing nutrients as well as a whole number of other parameters. So we often see spikes in nutrients immediately after a rain event. So you can look at any of them. They're all on our website. You can look at them. They're all open source, but there's none that we specifically have put like behind. It would be great if we could do that. The cost is prohibitive for that. But we are working on some integrative lower cost samplers that we can put in. Like, so when someone does put in a buffer, we could demonstrate the before and after impact. But certainly if you look at our Kilroy before and after a rain event, you always see this quick spike of nutrients, or very frequently, especially after there hasn't been rain for a long time, because that first flush is taking whatever's been there, been accumulating.
Okay, thank you. We have a request perhaps going out to everyone. And Jennifer asks if anyone has a good brochure for buffered stormwater ponds, not along seawalls.
Can I ask just a brochure, meaning how like a how-to sort of fact sheet about how to plant stormwater ponds appropriately? Would that be, or a brochure communicating their benefits?
Jennifer, if you have the ability, you can unmute yourself and speak directly.
So more specifically, it's just about residents, the residential ponds, or even possibly businesses that have just these regular detention ponds. So they've got the control structure and maybe one or two pipes coming from a parking lot, but around the actual pond itself, that's what we struggle with, is how to give material to that business owner. So if there's anything about like specific plant species, or even something that you had showed where it was a pilot project.
Oh, so communicating the potential benefits of the plantings themselves, or what their functions are?
Yes.
Okay. Let me think about that. There are documents from Gail Hanson, for example, looking at what plants that, but not that immediate educational information. But let me look for that for you. Yeah.
Great, thank you. I think one of our extension agents over in Manatee County, Michelle Atkinson, might have something.
That's what I was going to just go to, Michelle. Yeah.
And Basil, I think we have some clarification on your EDIS document. We have a question about whether or not there is a repository of plant species that's, oh wait, no, hold on, sorry. Is there a repository of the plant species used in the seawall buffer zone? So that's for Beth.
Not sure what you mean by a repository, like
a planting list, maybe?
We're working on that. So that's one of the things that we will have as part of this education materials that we send out. If we have the same issue that we talked about, there are some that exist, but they're not local. And so we are not the plant experts. So we're planning to work with Extension to make very specific recommendations for these buffered shorelines before we move forward. And then we even have a bit of a nursery. So we want to talk about like how we can grow some plants and make them available at low or no cost. So that's part of this project, but we don't quite have it yet.
Great. And Basil, oh, sorry, Vincent. Yes.
Yeah, I just wanted to mention to address that question a little bit more too, is the livingshorelines.com website, floridalivingshorelines.com website has some good guidance on shoreline plantings. and regionally specific too.
And Basil, your database also has a list of plant species, correct?
Yeah, there's a lot of plant species in there. And Beth, I wonder if you give me the list, we might have, it might not be geared towards what the style of planting that Beth's doing, but it can certainly give traits on the different plant species that are in Beth's plantings,
Right.
including salt tolerance. Yeah,
Right.
salinity tolerance, which is more important for the coastal. Right. Yeah.
Right. Yeah, I think the big issue is the communities that some of these homes are in. I mean, they're very specific on what the look they want. But
Yeah.
absolutely, yeah, I think, I mean, I'll definitely reach out to you because we need to be very consistent and thorough and give people exactly what they need so they're more likely to do it.
Mm-hmm.
Okay, Beth, the next question's for you, and I think you touched upon it, but maybe you can elaborate. Maya asks, what will be your means to reach out? And I'm assuming this is to the individual homeowners. Is it
So
flyer,
we
phone call,
actually
door
are-
hanger?
Yeah, sorry. So we are actually, I know in addition to things we always do like social media and news articles, we actually are going to send a letter to a home. So we will say, dear Mr. and Mrs. Smith, we noticed that you have a beautiful backyard with turf grass. I mean, I'm not sure, we're working on the wording, but the idea that's saying that I'm certain you're unaware that this could be contributing to some nutrients, even, you know, that. So it's gonna be very, very specific to the individual with presenting what's happening in their backyard, and here are some simple solutions. So it's a
Great,
direct
thank you.
mail.
Basil, the next question's for you. While collecting water samples in the Lakewood project, was there communication with the community regarding their general fertilizer schedule and content? Just curious if that impacted any nutrient levels.
Yeah, that's a good question. The short answer is no. These properties are managed by HOAs and landscaping companies that contract with Lakewood Ranch. And the assumption was that, you know, they were following, you know, IFAS and, you know, legal guidelines regarding fertilization, but we don't know. No, I mean, that's a tough one to actually quantify. You know, you have to get out there right after a rain and see what could impact it. So yeah, we didn't have a way of controlling for that.
Great, and also for you, Basil, Robin asks, oops, sorry about that, everyone. Was there any consideration in depressing the vegetative buffer planting area and slightly raising the top of the drain to, oh, nope, maybe this is
That's
for
for
Beth.
Oh.
Top of the drain to increase retention time to help improve nutrient removal.
Yes, so there was a lot of discussion about that. The reason that we didn't in that particular place is because the water tends to pool already. And so the city didn't want water held. And so that's why we didn't there. But certainly, you know, what we did at Jeffrey Park is one buffered shorelines. I mean, there's lots of others. I mean, simply putting a berm is a, you know, even a low one is an option. So that, and I mean, we would have liked to do that there. And that's why we just went with the rocks around the drains. I think it just depends on the specific site.
Great. Also for you, Beth, are you going to provide any type of incentive or help for residents to change their shorelines?
So that's something that we have to talk about with different cities and counties and funders. I mean, the city is excited about it. We're hoping that there will be perhaps, but we kind of have to get it going. So we need a lot of partners, obviously, and the city of Stuart is very engaged and excited about this. So as we move forward, we're hoping that they can think of something like that or offer something like that, certainly within our discussions. And we are getting some funding to move into St. Lucie and Indian River County a little bit, but you know, like it always comes down to where that incentive will come from, and hopefully the governments will see the value of it. And I think that's the idea. When we can start documenting the nutrients, the actually quantifying nutrients staying out of the lagoon, then it may have some incentive for that type of thing.
Great, thank you. We have a request from David, who lives in an HOA development with 5 ponds, and is wondering if you can send materials that he can share in an HOA meeting to showing the benefits of the plants, because many people will say, why should we bother?
Yeah, I'm happy. I'm sending you my email right now, and please reach out to me and I can send you what information I have. And then I also will send out what information I received that I'm going to be sending to Jennifer regarding the brochures and whatnot. So, yeah.
Okay, great. And last question from Maya. Do you have references regarding the reduction of nutrients from specific planting buffer zones and living shorelines? I've heard arguments saying that turf provides more nutrient assimilation than some buffer options such as rock. The only reference I have found is an EPA paper dated 2005, but it was geared towards natural forested buffer versus nutrient assimilation. Nothing more recent or adapted to Florida stormwater ponds.
Is that for me or Basil?
I think it's for everyone.
Oh, okay.
I'm still reading it. I'm rereading it. Sorry.
I mean, so that's why we're doing what we're doing.
Yes.
The before and after. I mean, I think we didn't find, I mean, there's quite a bit of literature, but there's nothing like on the nose. And so that's why we are specifically doing this before and after. So again, I wish I'd had that for you but I think we need to do some of that. And so, I mean, I think that's where we are right now.
And can I add to that with regard to stormwater pond plantings? We see an initial potential benefit, but there have been other studies that don't see a benefit. And I think what it has to do is, it's a complex issue, right? We dig this hole in the ground and we think that it achieves its goals by capturing stormwater volume. And we know that they're not working. So we're going to add some plants to the edge, but it might be more complex than that. I mean, really, we could be setting ourselves up for more problems by having plants that die and senesce every year, that go into the water and now decompose. So we need to really understand the mechanisms by which plants work, and then go ahead and design stormwater ponds up front. Or we might even need to retrofit stormwater ponds so that they're shallow littoral shelves, or something where, you know, we have to think about that. We have to understand the mechanisms a little more. I mean, you know, regarding bank stabilization, yes, that seems to be benefiting as long as the banks aren't too steep. But yeah, there are, you know, biodiversity benefits, you know, benefits to those sort of aspects, yes. But I'm a little leery to say that they're going to benefit every stormwater pond in every situation. I can't say that actually in good faith. So there's a lot of work that still needs to be done on the mechanisms and how to do it properly. Yeah.
And
the correct species.
I would just like to add, so for the waterfront properties, the lagoon properties, like the pictures that I showed you, I mean, really, I mean, if nothing else, the buffer keeps the grass. It keeps, at least significantly keeps the grass from just going directly in, which is what we see all the time. You just mow right up to the edge and it goes in. So in some cases it may simply be a physical buffer, but you know, hopefully we'll have significant data over the next year to help us understand it a little better.
And the second, that a simple no-mow buffer zone around a stormwater pond, yes, is beneficial just by not having grass clippings going in your water. So that's pretty, I'm pretty safe saying that, you know. So yeah.
This is some great conversation. Thank you. And I'm sure you all noticed because it popped up in front of your face, but we did put up the poll, the evaluation. This helps us determine what topics really resonate with you all as an audience, so we can continue to provide interesting and important presentation topics for you all. So if you get the chance, please complete the 4-question really quick evaluation. And we have another question for either of you. Do you have an opinion on floating stormwater plants that get maintained and removed on a yearly basis?
Yes. There is evidence there's some research done at UF that shows that they are effective at removing nutrients from the water. But I think the key here is that we get removed on a yearly basis. And one of the really interesting things about the stormwater pond or those stormwater floating plantings is there's evidence that a lot of what the benefits from that are not necessarily due to the plants themselves, but the actual microbial communities that live on the roots of the plants. So that's why I mean we really need to understand how plantings work, and not is it the plant, is it the microbial habitat we're creating? It's a mixture of both. But that's why I really raised up the issue of the microbial community as well. Yeah. So, but yes, there is evidence of that, and I can share I can share some papers with you on that. If you're interested, you can email me. Okay.
Great, thank you both. We are just pushing 1 o'clock. So I think we will end with Robin's comment, which is please keep us updated on your results, and thank you both of you. These were fantastic presentations, and it's super exciting to see what's happening in this field to try and get creative and innovative ways to reduce nutrients from our landscapes and engaging commercial and residential properties with that. So thank you both.
Yeah, thank
Oh,
you
thank
very
you.
much.
Thank you. Thanks for everyone for the questions and conversation.
Absolutely.
Appreciate it. All right. Care.
Bye, thank you.
Bye.